Hey Team 6-1, we are ready for the next video on energy, and it's about waves. And it's not talking about like waves in the ocean or waves on the beach, but it's talking about energy waves. And we will look at the difference between mechanical and electromagnetic waves. So here we go. By the end of the video, you should have a better understanding of waves, mechanical and electromagnetic, as demonstrated through your notes in your interactive notebook. Okay, just like we have been working on, you're going to get a reading. Make sure that it says waves, and then you will also need the page for your notebook. Okay, so if you need to, go ahead and pause the video and let's get started. Waves, mechanical and electromagnetic. One particularly important characteristic of energy is that it moves. It can transfer from and to various substances and forms of matter. One way that energy is transported is through waves. A wave is a back and forth or up and down motion that travels from one place to another with a certain speed and direction. The motion, back and forth or up and down, is called an oscillation. There are two main types of waves, mechanical and electromagnetic. I want to pause here. So the word oscillation, when we have fans blowing in the summertime, or sometimes I blow them in the winter because it gets stuffy in the classroom, and the fan moves back and forth across the room, blowing air back and forth across the room, that is called oscillation. It oscillates back and forth. Okay, so just to give you a real world example of that word. All right, continuing on. Mechanical waves are waves that travel through matter. These waves include sound waves and water waves. Other waves like visible light, microwaves, X-rays, and radio waves travel through empty space, as well as through matter. These are called electromagnetic waves. There are four main characteristics of waves: amplitude, wavelength, frequency, and wave speed. The amplitude of the wave is the distance a wave oscillates from its resting position. The larger the amplitude, the more energy carried by the wave. Wavelength is the distance from any point on one wave to the same point on the following wave. The frequency of waves measures the number of oscillations, back and forth or up and down motion, produced in a certain amount of time. The higher the frequency, the more energy the wave has. Frequency is measured in hertz, and 1 hertz is equal to 1 wave per second. Wave speed is the distance a wave travels in a given amount of time. There are two main types of waves: transverse waves and longitudinal waves. You know it's a transverse wave when the oscillations are perpendicular to the direction in which the wave travels. The top peak of a transverse wave is called the crest, while the valley or lowest point is called the trough. A longitudinal wave is a wave whose oscillation is parallel to the direction in which the wave travels and looks more like a spring. If you set a spring on your desk and pushed the end of the spring over and over, you create regions where the coils are closer together. Those are called compressions, and regions where the coils are farther apart. Those are called rarefactions. Some sound waves and seismic waves are longitudinal. And again, we're going to go over all these words because I know that's a lot of vocabulary. All right. So looking at your notebook page, you are going to want to cut out the characteristics of a wave, that circular rectangle there. And you're going to make flaps. So amplitude, that dotted line, you're going to cut that dotted line to the solid line. Then you have wavelength, and cut on that dotted line. Then frequency, cut on that dotted line. So you have 4 flaps: amplitude, wavelength, frequency, wave speed. The zigzag and that dotted line, as well as the solid line where it says time equals 1 second, that's going to be all together. Okay, so don't cut it out and throw it away, but that will be a separate piece. Okay, and then the spring down at the bottom, you're going to want to cut out that as one piece. Okay, and of course, our writing. Here is what your interactive notebook should look like when we're all finished. So feel free to grab some markers if you want to add some color. And again, we're going to glue this on pages 54 and 55 of your notebook. On page 54, this is where your reading will go. And I want you to take note that on the side, I want you to write oscillation is back and forth or up and down motion of a wave. Also, frequency. Frequency is the number of oscillations produced in a certain amount of time. And you should see this written on that paper as well. Page 55. There's a lot of stuff going on there, so take your time. Characteristics of a wave. That piece, remember, you're only going to glue the little tab so that you have the little flaps. Feel free to draw those pictures on those little tabs, but we are going to be writing underneath each one. So if you don't want to do that, that's fine. The next part should go that zigzag as well as the 1 second that goes underneath. Okay, and notice that it's labeled transverse wave, and then each of the hills, okay, those are called crests. Notice that they are all numbered, so I want you to also number them 1, 2, 3, 4, 5. The 5th one is where it's labeled crest. So when it goes high, those are called crests. When it goes down low, if you see in the pink underneath 5, that's a trough. Looking at number 2, wave 2, that is showing amplitude. So notice that goes with our first picture. So that's why if you want to draw the same pictures, it might be helpful. Between 3 and 4 is the wavelength. So feel free to draw that picture as well. Notice the wavelength is at the end of the crest of wave 3, and then it's the end of the crest of wave 4. So that is a wavelength. That was just one area that I showed. You can show other areas. So it could be at the beginning of 3 and then the beginning of 4 to show wavelength. Frequency is the number, and that's why we numbered them. There are 5 of them. And then the wave speed. Underneath where it says time equals 1 second. So there were 5 waves per second. 5 waves per second is our frequency. That's the number of times that it happened. And then the wave speed is like how long did it take. So that's 1 second. The next piece is with the coil. Okay. And remember, when the coils are all scrunched together, that's called compression. They are compressed. And so above those that are tightly packed together, that's compression. Then when they are spread out, it's called rarefaction. I'm not sure I'm pronouncing it right, but that's what I'm going to go with. And these are called longitudinal waves. Okay, if you're ready, then we'll go on. If not, please press pause. I'm going to give you the information underneath the flaps. Here's a closer version of that. All right, underneath amplitude. Amplitude is distance a wave oscillates from resting position. And again, feel free to pause so that you can copy all of these things down. Wavelength is the distance from any one point on one wave to the next wave. Underneath frequency, number of oscillations in a certain amount of time. And the wave speed, distance a wave travels in a given amount of time. Again, feel free to pause if you need to. For the writing, what is a wave and what purpose do waves serve in our daily lives? A wave is an oscillation that travels from one place to another with specific speed and direction. Waves allow us to see light, hear sound, and experience heat. For example, light waves allow us to see lots of color. And we're going to get into more details in another video. So this is just telling you that energy can travel in waves. Just as before, I want to show you what your final notebook should look like. Don't forget to take a picture of it and send it to me in Echo. And you know that I bought this from another teacher. She's amazing and saved me a lot of time to put this together. I just took her work and made it into a video for you. And so thank you to Jay Smith and her Read and Apply Energy Bundle. Okay. And don't forget, you are a Red Hawk. And so go Hawks!